Okay. Address Resolution Protocol or ARP. Wow, that just does not work. It always wants to that screen. I don't think you It's going the wrong screen. Someone do that. You didn't read any of that, did you?
No.
No, good.
I just never do them. Anyway. What?
Does anybody know what the purpose of ARP is?
It's to make sure that it's found in the right place.
That's really generic.
Okay, to make sure that it is found the correct IP address that you're looking for, and then,
It's the address resolution protocol, is that what you said?
Yeah, ARP is an address resolution protocol, but which address is it resolving?
the DHCP server?
No.
DNS server?
No.
Destination?
Yeah.
Oh my
goodness.
but.
Not ARP.
I don't think I know what it means. I clearly don't.
What other address?
Mac.
MAC.
And ARP changed to something else.
Oh, the ARP and
You're
net.
thinking ARPANET.
Yeah.
That's two totally
I was
different
thinking the same
things.
thing.
Yeah, two totally different things. So, ARP is used to resolve the address, the MAC address, and DNS is used to resolve the IP address. Okay. So, most computer programs and applications use the logical addresses, which is the IP, to send and receive the messages. Actual communication happens over the physical address or MAC. So, I'm going to do a demonstration here in a little bit that shows how the all the ARP messaging works. ARP, by the way, is an acronym. Anybody know what the definition of acronym is? Okay.
It's essentially little letters where each letter corresponds to a word. We did.
What if they're big letters?
Huh?
Yeah, what if
The
they're
big
big
letters. The big letters are the important letters. Little letters, not so much.
Okay, so is it big letters or little letters?
Big letters, I'm pretty sure.
Okay,
Was I wrong? Am I wrong on that?
I'm just giving you static, dude.
Oh.
It's like asking what someone what TLA means. Three-letter acronym.
Yeah. So acronym, it means that the first letter or a couple of letters of each word in a phrase, title, that sort of thing, are stripped out and used to form a new word. It means the same thing. Everything radar, it's actually radio detecting and ranging. A lot of people don't know radar is an acronym. You know, radar is just radar. So same basic idea. Anyway, and ARP runs at the data link layer, the layer 2 of OSI, which is still part of layer 1 on the TCP/IP model, the network layer. ARP is used to find the hardware address or the MAC of a host from its known IP address. So whenever you fire up your Wireshark, you do a filter for ARP. You'll see a lot of ARP protocols that say who is or who has this IP address. And then the network interface card, the NIC, that has that IP address says, that's me. Here's my MAC address. So then, each device knows how to access that particular IP address. Whenever you're talking about an Ethernet frame, you have source, destination, MAC addresses, and source and destination IP addresses are all part of that Ethernet frame. Okay. Reverse ARP, a protocol used in local networks, LAN, by client machines, requesting the addresses from, specifically from the router's ARP table. When a new machine comes online, which requires an IP address for its use, the machine sends a RARP or reverse ARP broadcast packet containing the MAC address in the sender and receiver hardware field. So, you guys remember what constitutes, or what makes up a MAC address?
Yeah,
I most certainly forgot, I didn't get those.
it's like 8, little segments of the like
groups.
4 groups of 8. It's in hexadecimal, right? Yeah, okay. It's a hexadecimal code consisting of 8 digits separated into 4 groups.
Oh, it's way up.
6 groups of 2,
Oh.
so 00 through FF on all 6 of them.
Mm.
Oh, it's F and then 10,
Yeah.
15 or letters.
I saw the screenshots from that.
I think.
Hexadecimal,
Yeah, hexadecimal.
0 through 9, A through F. This broadcast packet that's talking about, broadcast packet containing MAC address in the sender and receiver hardware field. In your Ethernet frame, you have, like I said, the source and destination MAC address. Broadcast on MAC is all ones. So F. When it does a reverse ARP, it just broadcasts, hey, I want to know who is. So your particular network interface adapter, NIC, network interface card, whatever you want to call it, is listening for 2 addresses. Its own address and then broadcast. It will respond to both. So, you have unicast, which is I want to talk to one person in particular. You have multicast, which is I want to talk to several at the same time. And then you have broadcast, which I want to talk to everybody at the same time. Okay. Some Macs will pay attention to multicast traffic, depends on who the manufacturer is. But they all listen to their own and the broadcast. Okay. Usually if you send a message out on the network and it's meant for Cabilly, I want to say, hey Cabilly, and then nobody else in the room is going to care who I'm talking to, right? Unicast, between me and you. Multicast is, hey, I want to talk to everybody on the front table at the same time. So these 4 people are listening, everybody else is, not me, don't care. And then broadcast, what I'm doing right now, I'm talking to the entire room. Hey, everybody picks up butt. Okay. So when I'm broadcasting, it means, hey, everybody pay attention and tell me specifically what I want to know. When I give that broadcast address, hey, does anybody have any questions? one person, Colton, gonna raise his hand and say, I do.
Well, no, MAC addresses.
Well, IPv6,
Oh, it doesn't, it's for IP addresses,
Yeah.
not MAC. But MAC addresses won't run out at all.
Well, yeah, because it's
well, it's
crazy.
still possible for them to run out.
Oh, wow. Even,
Because you have that's the OUI,
What's the OU?
organizational unique identifier.
Oh, so like all of the MAC addresses that come from the same organization are all gonna have that?
Yeah, you remember when we did the MAC
oh, okay.
exercise and I said, find out who the manufacturer is?
Yeah, that's good.
Yeah,
That's how it tells us from the OUI.
so is there like a subnet mask that would be like, what would it even be in this case, like FS, FFFF? Like is there subnet mask for MAC addresses? No?
No. But I mean, you can, the combination that you can have, there are so many, because you have letters and numbers consistent.
Yeah, if you have somebody that is a really major manufacturer like Cisco or Realtek or Huawei, you know, a whole bunch of them out there, they have more than one group of OUI. You know, if they're making hundreds of thousands of devices a year or, you know, whatever that time frame is, they know that they're going to run out of, well, you got 256 times 256 times 256, which is, what, 65, 535, is that? Oh, somebody do that math real quick. I'm pretty sure it's 65,
Wait.
535.
256 to the third is, yeah, 16,777,16.
Oh. Okay,
Cause I was doing,
256 squared is 65, 536. 16.7 million.
yeah,
Yeah. Yeah, Class A, if you break it into IP address, but yeah. So 16.7 million possible combinations from 000000 FF. So, you know, 16.7 million possible MAC addresses per OUI. But if I'm somebody like Realtek or Cisco, I'm making, I need more than one OUI. Oh, here's one.
You could look at MAC address like a phone number or something.
Yeah.
Wow, I didn't know that.
B4E025 is the OUI that is owned by IT Look, whoever that is.
Oh, you
It's a
need
Russian
the name and
Russia?
address, wow. I did not know that.
Anything being made in
Yeah, so
Russia.
anything manufactured by this company, IT Look, the OUI on the Mac, the first three octets are going to be B4E025.
and there's 16.7 million different companies that could, like different
No,
organizations.
there's 16.7 million different combinations of
Different companies.
device address that you can have under that one specific
We don't let them in,
OUI.
right?
So anyway, Colton, to answer your question, this OUI, let me zoom in and see it better. There we go. This OUI is registered to IT Look. Well, they have 16.7 million different network adapters that they can manufacture before they need to have another OUI.
Yeah, okay, I see. And then there could be, but there could be 16.7 million different OUIs too, right?
Yeah.
Okay.
So it's 256 cubed OUI. So are there going to be 16.7 million manufacturers of network interface adapters? Probably not. So, there is a finite number of them you can run out, but it's going to be a long time,
Yeah, it's
right? Okay, inverse ARP, use MAC address, find the IP. Inverse ARP helps to find the layer 3 address from the layer 2 address. What's layer 3 address?
The data link?
the router, the network.
Hold on, let me check my.
Layer 3 is the router, or routing
Networking?
layer,
So your public IP address?
IP.
Hold on, I have screenshot.
Layer 3 is IP, layer 2 is MAC.
Ah.
It is Mac, yes.
IP is network layer, MAC is data link layer. Okay.
Oh, alright.
I had screenshots of this, hold on.
Okay, so how does ARP work? Imagine a device wants to communicate with others over the internet, or any network for that matter. What's ARP do? Broadcast a packet to all devices of the source network. It's that broadcast FF until you get enough Fs. Which is the hexadecimal form of all ones. Devices of the network peel the header off of the data link layer from the PDU or protocol data unit called frame and transfer, or called frame. They transfer the packet to the network layer 3, which is IP. Network ID of the packet is validated with the destination's IP network ID. Packet, and if it's equal, then it responds to the source with the MAC address of the destination. So you say, hey, who has this MAC or this IP address? That's a broadcast, MAC broadcast. And then everybody that can hear that broadcast passes it up to layer 3 in the OSI stack and says, hey, which one of you out there has got this particular MAC address? Or, sorry, this particular IP address. That's layer 3 stuff. And then whoever has it says, that's me. Here's my MAC. Each packet that reaches the gateway of the network and broadcasts the packet to devices is connected with validation network ID. The above process continues till the second last network device in the path reaches the destination where it gets validated. That doesn't make any sense. I'd like to rewrite that. But basically, hey, who has this IP address? That's me. Here's my MAC address. So now we know we can populate our ARP table. ARP cache, after resolving the MAC address, the ARP sends it to the source where it is stored in a table for future reference. So,
I'm pretty sure I have command problems, not always.
If it's Windows, then yeah.
if you want to know what devices are in your, I can't zoom that in, cool. You wanna know what devices are in your local computer's ARP table? ARP minus A, or ARP space minus A.
ARP space minus A.
So
So that shows you all the.
line 2 is at this physical address.
Oh, would you look at that?
194 is at that physical address and so on.
So are those like different computers in the room or?
Anything that says 172.19 is on campus,
Okay, and then,
not necessarily in this room.
And the FFF thing, the whole, that's it broadcasting it out, right? Yeah, that's pretty neat
Yeah,
looking.
172.1935.255.
Oh, it's so nice. to
Dot
have.
255 in any network
It's broadcast.
is going to be the broadcast address,
why is that? How can you be so sure?
Because it's dot 255.
because that's how it is defined. 0 is the network and 255 is the broadcast. So hosts can only have from 1 to 254.
And those can change too, because they say dynamic, they're not gonna stay there. They-
Yeah, anything that says dynamic on it is possible for it to change.
Okay, so
Absolutely.
why did it cache those? Like what signaled that your computer needed to cache them?
At some point, it needed to talk to these addresses.
This one didn't
Okay.
change.
Oh, it
though.
just stores it there, so when it needs to talk to it, the information.
Yeah, so every time I need to talk to Cabilly, I don't have to go look up, hey, who's Cabilly?
Yeah, cause it stores that information for future reference. It's like a
ARP table.
radio access, a
Routing
radio.
table is something different.
I'm sorry?
ARP table, the routing table is something completely different.
Oh, okay, the ARP table. Let me be precise here.
Okay, so this 224.0022, 224.00251, 239, 255, 255, 250, those. Those are the Class D special use IP addresses. You'll find something similar to that on every computer that's connected to a network. And then there's 255, 255, 255, 255. Notice it's also FFFF. This is IP broadcast, this is MAC broadcast. So if I want to talk to every computer in the world at the same time, I route my traffic to 255, 255, 255, 255. Broadcast for everybody. Okay. Chances of me being able to connect to every computer in the world at the same time, pretty slim.
Super neat.
Okay, so like if I were to get on my computer at home and type in that like ARP-A, would I have like a bunch of addresses that it stored or since I'm not, okay, and would those addresses be like?
This is more for your local network.
Okay,
Now, you notice that there's nothing on here that would correspond with Google or
right, yeah, that's what I'm wondering.
Yahoo or Pepsi, or whoever.
Oh, that's pretty neat.
So you probably have like less addresses because since this is a big network, there's multiple.
Yeah, I'm actually surprised that I don't have more in here. Simply because this is a CAN. Remember what CAN is?
Yeah, campus area network.
There you go. Okay, so, ARP cache timeout indicates time for which MAC address in the ARP table cache can reside. It's like your DHCP lead time or your time to live TTL on
I love these.
on a ping request, ICMP request, that kind of stuff. Because what happens if my NIC dies and I've got to replace it? If I want to keep the same IP address, I can, but my MAC has changed because I had to replace the physical network card. It's going to have a different physical address. So the ARP is constantly, who has. And if that information changes because I had to replace my network card, then it automatically updates the ARP table with the correct IP address and MAC address.
So if you change a card, it assigns you a new IP address?
Well, if you're on DHCP, yeah.
Yeah.
But you can specifically say, this MAC address, always give it this IP address. So it's known as an IP reservation. The way I've got my network set up at home, anytime I add a new device, it gets a DHCP address, and then I go through and I say, no, I really want this MAC address to be at this IP.
That's when you set it to like static.
Yeah.
And it always.
Well, static implies that you have set the IP address on the device itself.
Oh,
IP reservation means that you're still using DHCP,
yes.
but you're saying if you hear a DHCP request from this specific MAC, always give it this specific IP address. There's other things that come across with DHCP, like gateway, DNS, network type protocol, server, a whole bunch of stuff you can do with DHCP. Not just IP. And we'll learn more about that in a few days or week or so, whenever we do the DHCP lecture. So your ARP request goes out as a broadcast, all apps, and then you get the response that says, hey, I am the one that owns this MAC address, and then here's my IP, which is what populates. Okay. ARP spoofing and ARP cache poisoning.
Yay.
So you can spoof your MAC address.
Mm-hmm.
If you do, ARP is not going to care. It's going to automatically update the ARP table. ARP ARP spoofing is a really good way to do a man in the middle.
Mm-hmm.
We talked about that on Monday, where I can pretend, or I can listen in on your conversation, you don't even know I'm there. Well, I can pretend that I'm the person that you really want to talk to. So you think that I'm talking to you, but I'm really talking to Aiden first, and then he's relaying everything I say to him, to you. Everything you say to me, you're actually saying to Aiden, and then he's telling me. Okay, so he's literally the man in the middle. As far as you and I are concerned, he's not there. DNS or domain name system is what we use to translate www.yahoo.com or YouTube or Google, insert your favorite website here, into its actual IP address. So, an IP address is similar in structure to this. I don't know if that's even an actual address or not. Just,
Put it into Google, see what it brings up.
yeah.
Good idea, I'm trying to do.
I mean, if it exists in the network, it will bring it up, right?
Probably
Oh,
not.
that's Bogon address.
Bogon?
Bogon.
What does that mean?
Special use.
Special use?
Yeah. Web browsing and most other internet activities rely on DNS to quickly provide the information necessary to connect users to remote hosts. DNS mapping is distributed through the internet in hierarchy of authority. You have the root servers, there's A through G, and they're distributed around the world. Some countries have multiple, they're in different geographic locations. And then they fall down from there. Most of the time, you're going to be talking to what is known as a non-authoritative server, because it's not the one that says this is what the IP address is. The authoritative name server is the one that says, I am the one that has the registration for this domain name, and here's the IP address, and then it tells everybody else. And they go, okay, well, somebody asked me, I'll tell them what you told me. So if you want to change your IP address, or if your IP address changes, you have to go in and update the authoritative DNS with the new IP address, and then everybody else gets told from there. When that's somewhat of a misnomer, though. The authoritative server doesn't tell every other server, DNS server on the internet. It just, if I happen to ask, hey, ISP DNS server, what is the IP address for Cabilly's website? And it doesn't know, it's going to query the root server. The root's going to say, okay, it's a .com. So I'm going to send you down to the .com people, and then the .com people are going to say, okay, what is the host name? Cabilly Jamira. So who has, or do I know who CabillyJamira.com is? No, I don't. So I'm going to find out who the authoritative server is, go ask them. Then they go back and say, okay, hey, this is the address for CabillyJamira.com. And then it's going to go back, tell the root, and the root's going to send the request back down to the non-authoritative server, and the non-authoritative server is going to tell you, hey, this is his address.
That's why a lot of stuff,
And it's all lightning fast.
and it times out sometimes too, while you're sitting there waiting, there's a long bar at the bottom saying, okay, requesting from there. So
Yeah.
if you really look, it's down there, yeah, on the internet, you can see it saying requesting this, requesting this. Sometimes it times out or something.
Well, if you're loading a web page that has resources that are accessed in multiple locations,
Yeah,
it has to go do the DNS queries for every asset that's on that page.
yeah, I see that.
That is hosted at a different location. You know, the primary information that's coming from otc.instructure.com is all served off of their server. But if this was, you know, full of ads for, you know, Viagra, you know, take these pills, make your boobies bigger, you know, whatever, then that's all on different servers, and you'll see a DNS query go out for every one of those assets. That's why the pipe hole works, because you can specifically say, hey, if somebody from this network sends a request to that server about anything, because, you know, this is a known ad server, just block it, drop the traffic. Tell the web browser that is requesting that information that the IP address is 0.0.0.0. That is null, which means I have no record of that. And then your web browser goes, okay, well, never mind it, and goes on live. Instead of going and fetching all the ads and bringing them in and cluttering up your screen. DNS mapping is distributed throughout the internet hierarchy of authority. I just told you about that. Access providers and enterprises, as well as governments, universities, and other organizations typically have their own assigned ranges of IP addresses and an assigned domain name. So, get this back up here. If I do in this lookup for otc.edu, comes back with one otc.edu. That's the only address that will get you to the OTC web server. Okay. If, however, I do this lookup for Google, you point your web browser at any one of the addresses, it still gets you to google.com.
Is that just because there's that many different servers? Google has that many different servers? And I noticed some of those are IPv6 servers, so.
Yeah, Google is big enough that they definitely are adopting IPv6, but you notice they got plenty of IPv4 still available.
Yeah.
Because the vast majority of the world has not adopted and may never adopt IPv6.
Yeah.
I'm gonna go ahead.
Well, you notice here it also says non-authoritative answer.
Yeah,
That means that I just did an NS lookup. I didn't tell it to use a specific DNS server. So it used the one that it knows about that was assigned to me, this computer, by DHCP. This happens to be the DNS server that's here on campus. 172.30.0.42. 172.30 falls within the Class B address range for private IP.
okay. And say you made a little, like, pie hole thing, then the address of that pie hole would be, and
It would be right there, yeah.
yeah. Does OTC's DNS server have any ad blocking?
No.
Yeah, he
There's
knew
nothing?
I didn't, but they explained it. He doesn't know what pie hole is. I don't think he was here last time.
I think I just must have missed the pie hole.
He was.
Pie hole is a,
Pi-hole is essentially a network-wide ad blocker.
Ah, okay. All right. Great.
That's what I.
Command space / question mark. Those are the options that I can use. Go to NS lookup, no option, and I just typed in the host name, google.com. Just look up the host using whatever the default server is, so whichever one DHCP said to use, then that's the one to use. I can NS lookup and say, what's your favorite website?
I like Amazon.
Instead of using the default, I'm going to say go use Cloudflare's 1.1.1.1. Apparently Cloudflare doesn't know,
Who,
or
Amazon?
we couldn't get to it, one or the other. Well, it's there.
Huh.
It's also possible that OTC has blocked
Cloudflare.
access to Cloudflare for the purposes of DNS.
Why,
So,
what does OTC stand to gain from locking down the DNS?
we're fucking up their network.
That's Google.
Yeah,
Yeah.
yeah.
That's one of the Google DNSs, yeah.
So you can only use,
Yes. It knows it's Google DNS.
how do they do that anyways? How do they keep you from using other DNS?
Just block port 53. DNS's default port is 53. You can also do secure DNS and DNS over HTTP and DNS over TLS, a bunch of other things like that, but the default DNS is always port 53.
What's port 80 again? I know port 80
Web.
is really important.
Web,
Web.
HTTP.
How many ports are there?
65,500.
Oh, wow. Is that 256 squared?
Yeah.
Wow, that's a lot of ports.
Just
Okay, so,
I'm not late, am I?
whenever you want to use, go visit a web page, you say, I want to go to Amazon.com. And the browser sends a message known as a recursive DNS query to the network to find out what the IP address is or the network address that domain corresponds to. Query goes to recursive DNS server, which is also called a recursive resolver, usually managed by the internet service provider. If the recursive resolver has the address, it just returns it. So, common places like Google and Yahoo and YouTube and things like that, that a lot of people use, it is extremely unlikely that your ISP's recursive server will ask anybody what the address is. It should already have that information cached. If the recursive resolver doesn't answer, we'll query a series of other servers in the following order: DNS root, top level domain or TLD, and then the authoritative server. Three server types work together and continue redirecting until they retrieve a DNS record that contains the queried IP address. Sends this information to the recursive DNS server, and the web page of the web page the user is looking for loads. DNS root name and top level domain servers primarily redirect queries and rarely provide the resolution themselves. It's more like they never provide the resolution themselves. It's not the way DNS works. Go to the root. Root says, who you want to talk to? .com. Okay, well, .com is handled by this top level domain. And then it says, hey, top level domain, where is yahoo.com? It says, I don't know, so I'm going to send you to who's the authoritative name server for yahoo.com? Okay, that one. Hey, authoritative name server, who is the, or what's the IP address for yahoo.com? It says, here it is, and then the whole round robin thing. Eventually comes back to your local DNS server, and then it caches the information. So when you or somebody else makes that same request, it says, oh, I know where that's at. And it doesn't have to go through all that extra bull stuff. Okay. DNS structure, domain name usually contain is usually contained in the URL. Anybody know what URL is?
What was it called?
What it stands for?
Uniform resource locator.
Uniform Resource Locator. Ooh,
Man, what a smart.
we looked it up.
Yeah, you use that one, huh?
Use my resources.
I know what the URL means.
What was Rule 2
What the
again?
definition is not.
Okay, so the top level domain appears after the period in the domain name, so .com, .edu, .org, many others. Some may denote a country code or geographic location, such as .us for United States, .ca for Canada.
That's what I was gonna ask.
WK for.
Those extensions, what do they mean? Cause they always come up with new ones like .org, .fm, whatever.
.gov.
.io,
So who
.io.
determines what the extension is, like .us?
IANA,
You determine what it is?
IANA,
Who's that?
Internet Authoritative Name, Internet Address Authority, Internet Address Name Authority.
So com is commercial, right? That means just,
Typically, yeah.
so they go depending on what I am, like if I'm a business or if I'm an organization. So I will fall under different. And what does that do? I mean, why isn't everyone just com.com? Why?
Well, because some people are not-for-profit, some people are educationally, some people are government.
And so the more.
The original TLDs were .com, .edu, .gov. That was it.
That was it. And then now.
And then they just came up with the idea, hey, you know, meaningful, domain names are starting to get kind of scarce. So if we divide things out a little bit more, you know, if you are specifically a website for a particular TV station or a TV show, then you're .tv. If you know you're strictly porn, nothing else, then you're .xxx.
Oh.
You know, there's a whole bunch of.
Like different countries too, like Canada would be .ca and Australia's .aus.
That's just categorized.
Australia.au, but yeah.
Keep everybody in a category so to make it easier to. I see.
Yeah, if it is just .com,
Yes.
chances are it's in the US. You know, it's like Amazon.com is US Amazon. Amazon.co.uk
Oh.
is Great Britain's Amazon.
Yeah, okay, I've seen that. And sometimes I'll try to follow a link that's like, you know, Amazon, like .au, and then it'll just be like //, and then.
So I'm asking another question. So if you're in another country and I'm over here and let's say I type in certain domain name and you type in the same domain name but you're in another country, are we accessing the same information?
Yeah.
Because I feel like sometimes like we're not accessing the same, like the information that we access here.
Well, if you're going to Amazon.com, you know, if you go home, go to Amazon.com, you're not gonna get Amazon.com because it's gonna know you're not in the US. So it's going to take the Amazon.com, look at your IP address, which is going to tell the DNS system where you are physically located in the world.
And then route.
Based off of your IP address, and it's going to say, okay, I'm smart enough to know that I'm not going to send this query to Amazon.com US. I'm going to send it to Amazon whatever for whatever region of Africa that you're in.
Yeah, that's what I was wondering, but then that means we're not
Right.
accessing the same information because I'm here.
Well, it's still the same information. It's just how do you get to it? Because
Oh.
all of the Amazon servers talk to each other. They all access the same database. It's also going to know that you're probably not going to be paying for whatever it is you're buying through Amazon using US dollars. So, you know, it can converted on the fly into rupees or pound sterling, Canadian dollars, you know, whatever your form of currency is. Different types of DNS. You have recursive. Those are ones that take place between the recursive server and the client, which is basically you. Iterative takes place between the recursive resolver and non-local, like root or top level. So the iterative would be your ISP doing a query on your behalf. Non-recursive for those which the recursive resolver already knows where to get the answer. So I don't have to go ask the root or the top level domain where to find this asset. I already know. So I don't have to do that recursive lookup. All I gotta do is say, hey, here you go. Common DNS record. A record is address. That's the IP address. Okay. NS record is name server, which tells the DNS where the authoritative name server is. TXT record allows you to enter text into the DNS. Original purpose was to put human readable notes in DNS, but today machine readable notes are often put there. Use confirm domain ownership, secure email, and things like that. It's pretty invisible to the end user. And then CNAME is a canonical name, which is an alias. So, you know, Nathaniel is Nate's given name, but he also will respond to Nathan, Nate. Hey, you got any nicknames?
Family calls me Buddy.
Okay. So Buddy would be an alias. CNAME.
So it's just like if you wanted to go to your Google contacts, you'll type contacts.google.com. Instead of having to go to google.com, then go to that top tab, clicking, so that.
Contacts.google.com will be a subdomain.
Awesome. So what's CNAME, like how you just explained it?
Well, if you're going to visit KabilityDemir.com, maybe you have that shortened up to KD or KD, something like that, .com. If you ever embed a YouTube video into a web page, it's not youtube.com, it's youtu.be. It's a URL.
URL.
So youtu.be is a CNAME or an alias for youtube.com. If you look specifically at the IPv4 addresses,
Oh.
they're identical.
Those two that you just highlighted
Oh, no.
are not identical.
Oh, 114 versus 115, okay. Yeah, if it was a true alias, it would be identical. I would be willing to wager that 114 and 115 are physically the same server.
That was really neat.
But you got 190, 190, 91, 91, 93, 93, 136, 136. So the fact that they are 114 versus 115, I say that there's a really good chance that they are still the same physical server. So how does DNS increase web performance? Servers can cache A records or IP addresses they receive from DNS queries for a set amount of time, that is TTL, time to live. Most efficiency enabling servers to quickly respond the next time a request for the same address comes in. Yeah, there it is, time to live. Okay, longer time periods decrease the load on servers, shorter ones ensure the most accurate responses. So if you have a dynamic IP address that, periodically changes, you want to shorten up your TTL for that A record or CNAME record. And bless you. You good?
Yeah.
Okay, thought there was another one coming. Anyway, if you have a dynamic IP address that's constantly changing, you want to shorten your TTL so that the record expires and it has to be requeried. If you're a Google or YouTube, your IP address doesn't change. So your TTL can be, 365 days if you want to. It's not going to change anything. So that's what that means. DNS cache, the goal of DNS caching is to reduce the time it takes to get an answer to a DNS query. Anytime your computer does a DNS query, it stores that information in its own cache. So when you say, I'm going to otc.edu, it's going to first say, hey, do I know where that is? I do, great, I'm just going to go. I don't know, okay, I'm going to ask the DNS server. If it knows, then it comes right back at you. If it doesn't know, then it does the recursive lookup and all that stuff. Either way, after the first time that you visit that site, it's stored in your cache. Okay. It helps them. I put DNS flush and flush DNS. Okay, we'll get this right eventually. There, successfully flushed all of my DNS resolver cache.
So now everything's gonna take a split second longer.
You can take just a little bit longer.
I use the task manager all the time because my computer
Okay,
is so old.
so
I always need to see what's eating up my.
since I have flushed my DNS, there we go. Standard query for A record when ATP dot or dash DJ standard query response. Here's the address. CNAME was somewhere on the Azure server. Okay, I got my web browser open on the other monitor. Okay. I'm going to do a www.amazon.com. Okay, we'll pause this. So my initial query was to Amazon.com. There was also one that went out to Google Ad Services because there are lots of ads that show up on even Amazon's website, even though they serve their own. So Google Ad Services, images.amazon or images, blah, 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 or Google Ad Services, media.amazon.com. So all of this has to do with, that's an ad server. All this has to do with my simple one request to Amazon.com.
And yeah, all that traffic
Yeah. Because of all the assets that are on
on there.
the Amazon.com made.
This could be slowing up your network in some way, just
Oh, yeah.
by visiting Amazon.
Well, and those like, those ads
If
too.
you have a cap on the amount of bandwidth that your ISP provides, you don't have to pay extra for.
Yeah.
That's one of the prime reasons to put an ad blocker on your network, because they're not constantly fetching that crap that you don't care two shits about anyway.
Yeah, that's why I have Fire Stick. So it's probably, like you say, using that Amazon web server.
Oh, yeah.
And it's eating up my internet, right?
Oh, yeah.
Oh, man, I mean, now that you show me all that stuff is going on, I'm pretty sure it's probably going on in my network too, and I really don't want none of that.
But if you look at this, you know, I went to Amazon.com and right there was the last query. Before I said, hey, web browser, go to Amazon.com. And all I'm looking at here is DNS traffic, the protocol for DNS. Okay. Look at all that shit.
Yeah, no. That's why sometimes my internet is kind of slow.
What's the name of that program again? Shark.
Wireshark.
Wireshark.
Because these things.
Don't they have a VPN too?